Okay, you guys have an answer now. Yes. Google. ChatGPT. Okay, yeah. So we'll be looking at moment of a force, and particularly we'll be looking at in 3 dimensions. I will concentrate in 3 dimensions. I pretty sure that when we talk about 2-dimensional moment, you guys already know what it is. Since we're defining moment as the turning effect of a force or the turning effect produced by a force on a pivot, that's more inclined to 2 dimensions. So what we're simply saying is, let's say we've got a pivot here, and we've got something here, and this object is pivoted here, right? And there is a force here, okay? There is a force acting here. So we are defining moment as the turning effect that is going to be produced by this force on where? On this pivot, okay? So when this force is applied here, this is going to do what? It's going to turn like this. This turning effect that is being produced is what we're calling moment, right? Yeah, that's what we're calling moment. And in some cases, you might hear that it's called torque, okay? Denoted by what? Eh? Theo Bender. It's tau, okay? Yes. Eh? Tau. Yes, it's what's this? Oh, it's a letter, not in the English alphabet. Another, yeah, it should be Greek. Yeah. Right. So it's measured in Newton what? Meters standard. Okay. But you might find that maybe it is in Newton millimeters. Yeah, but for your case, your answer needs to be in what? Newton meters. Right. So in the 2D, when we talk about the 2-dimensional space, we know that when finding moment, you just have to multiply the force times the perpendicular what? Distance. Okay? That's very easy for you to do. So here we find that the perpendicular distance is this distance here, right? And the force. If let's say we had something like this where the pivot is here, okay, we have something like a pole and it's pivoted here, right? And there is a force acting here. The perpendicular distance is going to be what? The distance from here to the what? The pivot. Basically, it's making a 90 degrees with the what? Yeah, the pivot. With the force, sorry. Yeah. So if you check here, there's a 90 degrees. If you check here, there is what? A 90 degrees. Okay. So once we look at that, the other thing that you need to know is what we're calling the line of action. Do you know what that is? The line of action. What's the line of action? Yes. Yes. No, the line in which the force is acting. Guys, line of action. Okay, I don't know how you define it, but I'll just tell you that this is the line that is passing through what? The pivot, okay? So here the line of action is, let's say it's ending like this. And here it's where this one. And the reason I'm bringing that up is because I want to tell you that when a force is acting in the same direction as the line of action, it has no effect. Okay. So basically, when you have a force that is acting here, but the force F like that, it has got what? No effect. It's not going to produce any what? Any moment. Right? Even here, when you have a force like this, it's not going to produce any what? Any moment. That you guys already know. If you've got a if you've got a force that is acting at an angle, we know that we can't deal with this. Firstly, we have to resolve it in its what? Components. So you resolve it in its components so that you get the x component. This is the y component. Eh? Yeah, you get the y component and you get the what? The x component. The x component isn't going to produce any moment because it is within the line of what? Line of action. Okay. But that one is going to produce what? Moment. So that is in the two-dimensional space, basically. So I don't know if you guys want us to look at an example. No? Okay. All right. So now, when we talk about the 3D, okay, let me just have a question. Let me write a question so that we base our 3D discussion on that. So this I'm looking at question 3 from the tutorial questions. Do you guys have the tutorial questions? This is chapter 3. I used to be I used to be a good artist at some point. Oh, ah, school, school happened. Eh? Ah, ah, ah. I'm telling you guys. But okay, people who just know statics and dynamics are good at art. I'm telling you. Hmm? My drawing is bad compared to. Okay, but you refer to the so that have to pass. Or maybe we have got an artist in this class. We just don't soon to be. At once you do what? You can try. But I'm almost done. Okay, so we've got here. We've got one. Okay, so here we've got 7. I'm doing mechatronics. It looks just okay if you look at it first. So it's making sense. Okay. Which other point? But and you guys have got ile moneka tunamukwata kale ile moneka bwona so yena mutayimoneke bwona is 0.75 here distance here. Bishop paliyo nshire po distance. I've covered everything, right? Okay, this is the y. This is x, and where is z? This one here, and this is our origin. Okay, so we will base our I'm going to call it our model for 3D based on this question. So basically, when you're dealing with 3D, what's the question asking first? Okay, so let me explain what is happening here. What is happening here is that, okay, imagine this. Murefu okutema ekimuti, chai. Then you don't want it to fall this other side. You are thinking that, okay, let's say kuringando side, right? And you want it to fall this side. So you've tied it with what? With ropes. Okay. So these ropes are exerting a force. Okay. And that force is called what? Tension. Okay. So there's a tension force in these ropes pulling this side. Okay. So the pivot here is this point, the origin, right? Yes, because upward, okay, that is where chichimuti chikatire punch. Okay. So imagine there was just one rope. There was just this rope. Okay. Ita iliko. When we pull this rope hard enough, this tree will fall like this, right? Okay. It's like this. When we pull this rope hard enough to fall like this, okay? Yeah. Ingata yachibakwe. If we pull uh, if we pull this rope hard enough, it will fall like this, right? Yeah. So now, since shirishibiri, um, it's going to it's going to fall like this somewhere here. Okay, that's not necessary. I'm just telling you. Okay, it's going to fall like this. So the whole idea is we need to find the moment that is being exerted by these two ropes at this point, the origin, right? So for you to do that, what you need to first do is find the moment, assuming that takudi in dam, okay? You just assume that there is this one. You find the moment, then you come and assume that itakudi, kudifia yeka, you find the moment, then you sum up the moments, okay? So since we are talking about moments in 3D, you are going to need to resolve your forces into what? Yes, into Cartesian form. Okay, so your force needs to be in what? Cartesian form. The same way in two dimensions we were having at the moment is equal to the distance, the force times the distance. When we talk about 3D, the moment is going to be equal to the distance r times the force in what? The force in Cartesian form. This distance r is 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 going to be any distance from the origin to the force. Okay? So any distance that is going to move from the origin to the what? To the force. So that distance can be, we know that for this line, um, for this line, the force is being exerted on the entire line, right? Okay. So The distance can either be, you can move from here to here, okay? You can move from here to here, you can move from here to here, from here to here, as long as you touch what? You touch the force, okay? The line of action. Oh, is that the line of action? Okay. Okay. So as long as you touch the what? You touch the force. So as you will be answering, you will need to make your life easier and get a distance that is going to be easy for you to find. Okay? Not okay, now I'll move from here to here. This will be my R times my F. Okay? You need to get a distance that is what? That is easy. Okay. The whole idea is you need to touch the what? The force. Are you understanding? The whole idea is you need to touch the force. Okay. So for this one, the best distance you can select is moving from the what? The origin here to point. What's this point? It's B. Okay. Okay. If you come here and this is your R, this R is going to touch what? The force. Again, when you come this side, you're going to use this same R because it's going to touch what? This other force. Are you understanding? Okay. So, what is this R we're talking about? How do we find it? It's a what? Okay, good. Okay, so it's a position what? It's a position vector. So it's basically you just basically move from the origin to what? To this position. That's R. So you need to write that So you need to write that position vector. So let's write it. So the position vector for this one is going to be what? We're moving from the origin going to B. So me, I don't know how you do it, but you just have to do it in one go. I hope you don't say first. You write the coordinates for A for O. You write the coordinates for. That's not what you do, right? That's what you do. Time. It's okay, but I would advise you try by all means to. Eh. Oh, so doing it in your head is okay. Okay, I understand it. Okay, so for this one, the x, this is the x, right? So for this one, in the x, we are not moving, right? These markers, I'm trying to find the marker that is. Okay, so for this one in the x, we're not moving. It's going to be what? 0, I, okay? Plus in the y, are we moving? 7, okay? So we are going to the positive. It's going to be 7, j plus 0 what? Okay, okay. So we've done that. The next thing that we need to do is we need to the next thing that we need to do is we need to write our forces in what? In Cartesian form. You guys already know how to do that, right? Okay. So basically, these forces are acting from B to what? This one is acting from B to what? So A is here. So we're moving from B to what? To A. So we know that when we're writing a force in its Cartesian form, firstly we need to find this what? This distance, the position for from B from B to A. So you can do that. You need first you write the coordinates for no. Okay, so we are moving like this. We are moving like this. For us to reach A, we are moving like this. We are at B, right? We'll go down first. That is what? That is negative 7. This is Y, so it's J, right? So we'll go down. Then we'll come like this. This is Z. We are moving like this. And this distance is what? 6. Are we going to the negative or to the positive? Positive. So that's going to be 6 what? K. Okay. Then we are going like this. Going like this. That is what? Negative 0.7. Since the positive is this side, we're going to the negative. So it's going to be negative 0.75 I, right? So that is the distance from B to what? To A. Okay, what we have here. Now, guys, was that hard to do? Eh, huh? Which one? That's okay. All right. So we're saying that B A is equal to negative 0.75 minus 7J plus 6K. Okay, that's what we have. The next thing that we need to do is we need to find the magnitude for this, right? Yeah, which is going to be AB. So it's going to be 0.75 squared plus 7 squared plus 6 squared. What is it giving us? Okay, so it's giving us 9.25. Yes. So, the writing, I was supposed to show that it's correct, or maybe you can just write the number. No, you need to show. Just, yeah. Okay, it's giving us what? 9.25. Okay, so that's what we're getting. So from that, what we just want to do is finding the unit vector, right? Yeah. So all we want is to find the unit vector. So I'm going to do it like this. The force BA, this force is equal to um, the magnitude of the force times the unit vector, right? Which is BA over its magnitude, right? Yeah, so that. So what's this force? What's its magnitude? 555. So it is 555. It's going to be 555 times over. Okay, I'm just taking this one outside. Okay, I'm just taking this one outside. So it's going to be 9.25 times this. It's 0.75 minus 7J plus 6K. Okay. Tell me what it's giving you. Negative 45. Okay, so you're getting negative 45 I minus 4 what? 420. 420 J plus 360 K, and remember the units. This is in what? Newtons. Okay. Right. So that's what we're getting. We have expressed that one in Cartesian form. The force in Cartesian form. Okay. Have you guys seen the way I'm writing? if you want to save time, I don't know how you do it. How do you do it? Do you know first the unit vector one, you get the, you stopped, yeah? Okay, yeah. So okay, so you can adopt this one if you want. Okay, where you just write it like that. But have I left anyone behind before we continue? We are all following. All right. So you get that. We already have our what? Our R. So we can now proceed to finding the what? The moment for this force. So mfuta hapa pen uko nanisha hiyo. I give you a minute to write. Okay. So now when we are talking about moment in 3 dimensions, what we do is we don't multiply the way we multiply in 2 dimensions. Rather, we determine it like you're finding the what's this the determinant of a matrix. Okay, so the moment is going to be equal to R times F, which is equal to a 3-dimensional what? Uh, the determinant of a 3-dimensional matrix, which is going to have I negative J K. And what is going to follow in the second row is supposed to be R, okay? So that's going to be, for this one, we have, it's going to be 0, 7, 0, okay? And our F finally, which is this, negative 45 minus 420, 360. This is what we are going to have, okay? So now, all we need to do is we need to find the determinant. And by the way, do not swap these, okay? Do not swap these two. Do not forget the negative. Are we clear? Okay. All right, so this is going to give us what when we are finding for, guys, mwadishi mpaka ifya kusanga determinant, right? Okay. Now tuishi babonze fya kusanga determinant. We skip this part. Okay, so when okay, when you're finding for I, you just basically hide this, right? Then you say this one times this one, and then this one, you get 0. So it's going to be what? What's the answer? 7 times 360. 2,500. 520. I. Okay. Then for J is 0. Okay. Plus 0 J. And for K, 315. K. Okay. And this is in what? Newton meter. So you guys, do you know where do you know where the Newton meter is coming from? This one, na ikwata nani kan? Na ikwata ma meters. This one na ikwata sham. Na ikwata ma newtons. All right, so that's the moment for what? For this force. Now we need to find the moment for what? For the other force. Since all of you have said that now I understand, find the moment for the other force in to find the moment for the other force in 10 minutes is the I gave all that explanation. The video was paused. It's a loss for people who be watching.
No, when
Yes,
I
I
add the
paused it
forces,
and I forgot.
it's giving me a different data.
When you do it, when you add the forces,
Yes. When you add what? When I add the forces, it's giving me like 7 and 8. It's giving me another. Maybe we'll put it here.
what did it?
What
What
was
did
the
it?
total force after adding the forces?
91.
7.
791.
What's the data?
It is 791. It's 791
No, like not the final answer. The forces after adding it.
after adding them. 297.
And what?
So 295
And
and
what?
980 and 440.
No, but hey, oh my god.
Okay, try to look at question. Try to look at question 5. Do question 5 or we go to question 7. Which one should we look at first?
5.
5 or 7? 6.
5.
6 is long.
6 is long.
Mm.
Very much. 5.
We do 5.
Yes, then we'll do 7.
We said that we're doing what? 5. I think this one would be easy to draw. You're the artist. Then no one wants to do mechatronics here. It's coding, I should passion. No, like guys, it's just the attitude that you have towards this. It's bad. Eh? Although it's you people. Girls, you don't like programming. That is graduating with what? With a distinction. Hmm? That's a huge development. Yeah, someone with a distinction with six. That's a development. Eh? I could bring people graduate. Especially just go for super engineering. Mechanical. Mechanical is hard. Mechatronics is Sad. Okay, man, it just depends with the lecturers that you have in a given academic year.
Like us, like when I
Yeah. I know you guys. It's easier now. I'm telling you. The West guys. Yes, Mr. Sokotera is gone. The teacher is gone. Yeah, he was good. Yes.
now this one, he only teaches one thing about.
Okay, I think Fiakwana, Fiunzai. Okay, what are we finding? Determine the moment of F about A. So, F of this force about point A. It's F. Achan? No. A the origin. The origin is here. So F is this is our force. Alright, so our force is here. Starting from this point, it's acting on this rope here. So it's a tension force. Our R, our pivot is where? It's A, it's here, our center point that we're looking at. Okay, it's A, right? So our R has to move from A to any point on the what? On the force. So it can move from here to here. This can be your R. Or it can move from here to here. It can also be your R. And if you are that good, you can pick any other point up. You can pick any other point. So before which one should we look at first? We look at R or we resolve the force? Okay, so let's look at R. Which one are we picking?
from A to B,
From A to B. Okay, from A to B. Therefore from A to B. Okay, so we need to move from A to where? To B. So we are going to go down up to this point and go down up to this point. So we need to know this distance here. All right. So since I know that this is a right angled triangle here, and it has got yes, there's an angle somewhere. I'm seeing 45 is where it's here. 45 is here. Okay, so this is 45, meaning that this is also 45. So I need to find this distance. You can either use the triangle down below or the one above. I think the one below would be easier to use. We're trying to find this distance. And we know that this distance is the same as the distance here, right? So I'm going to use the triangle that is below. I'm going to use this one, which has 45 here and 4 as the hypotenuse. I'm trying to find this one. Okay. All right. So that would be y is going to be what? 4 sine 45, right? Guys, am I that too ahead of you? Eh? No, I'm just nilete. Okay, nikanindika po B. Nikanindika po kasmo leta A. Therefore, nika distance when therefore. Just this distance. Are you following me? Yes. So that distance, Nifin and Dembele. It's okay. Okay. It's giving us what?
2.8.
Penny fraction.
2 roots 2.
So it's what? 2. Sorry, that's a bad. Okay, so it's 2 root 2. This distance here is 2 root 2, which is the same as the distance where here. So the distance here is 2 root 2. All right. So me, the distance I'm interested in is this one here. So this other distance is 4 minus this other, since the total distance is 4, the other distance here is 4 minus 2 root 2. Okay, I'm paying for my points because I know it's going to give you, it's just going to be 4 minus 2 root 2.
1 plus 1 is
Eh? Eh? So, eh, eh. Oh, so from teenager. So this distance is what? 1.17, okay? And this one is 2.83. Okay. All right. And I think we are also going to need this distance here. This distance here. They're the same. Eh? Uh, 45, 90, 45. Oh yeah, they're the same. All right. So this distance here is also 2.83. Are we together, guys? Luvinda, are we together? Nika triangle fyaka tule chitanani gani. So navuma mfua distance. A distance. Alright, so since we have those distances, next thing that we're going to do is now find our R. And that is going to be, we are moving from A to this point, okay? In the what? Should be clear. This is what? The Z. Okay, this is the Z. This one is what? The Y. This one is the X. Alright, so we are moving negative what? 1.17 in the what? In the Z. So in the Z in China. Okay. Okay. Z in K. Oh yeah. So we're moving like that. Then we're going like this. That is in the what? In the X. And that is what? Positive? Yes. So that is 2.83 I. And we haven't moved in the what? In the Y. So in the Y it is what? 0. Okay, so we found our R. Our R is equal to 2.83 I minus 1.17K. Alright. So we just need to resolve now our force, right? So for our force, we are moving from B to what? What's this position? C. Okay, so we're moving from B to C. BC is equal to what? Okay, we're going to go down like this. That is in the, so that is in the Z. So in the Z, we are going negative 2.83. Okay, so we move down like this. Then we'll go like this in the Y. Okay, in the Y. So that is what? 6 in the Y. So it's going to be positive 6 what? J. And we haven't moved in the what? In the X, which is 0. Alright. Okay. And our magnitude is what? What's the magnitude? 6.63. I don't trust you. Eh. We haven't moved in the x, like from this position. Oh yeah, we have moved, guys. There is even a gap here. Yeah, so we went down like this. We went like this. We need to go like this. So there's a nine can happen. So since this distance is what? 2.83. The total distance is what? Is 6. So it's going to be 3.17. Okay, guys, chiteni so. Man, chiteni so. Get the coordinates for B. Get the coordinates for C. So that you are not behind. So the, yes, okay, so this triangle, the distance here is also the distance here. You get ka? Yes. So this distance here is 2.83. Even the distance here is 2.83. Now the distance we are only interested is the remaining distance here. Okay? Yes. So now we just have to subtract this distance from 6 so that we get the remaining distance. But if younger Fiashupa, just get the coordinates for what? For B, get the coordinates for C and do what? Subtract. Oh yeah. We are going to the positive. Yes, we are going this side. So we're going to the positive basically. Yes. Yes. B, you are coming from B going to C. So you are going to, it's going to be C minus B. Yes. Yes, you refer to the origin, everything. So basically your points for B are going to be in the X, it is 2 point what? 2.833. In the Y, it's going to be what? 0, right? So it's going to be 0 in the, so it's going to be plus 0 in the Y. Then in the what? Z. Z is going to be it's going to be the same. It's going to be 2.83. Okay. Then for C, which is here, you are going to have what? You're in the X, you are going to have the distance from here is 6, right? So it's going to be 6I plus what? In the Y plus 6, okay? J, then in the Z, it's going to be what? 0. So you are going to say C minus what? Minus B. So ekyakwangukira fyokubombi. Since you are moving from B going to C, it's going to be C minus what? B. You get your none can. So this isn't supposed to be 0. It's supposed to be what? Eh? Supposed to be 3.17. Is it positive? Yeah, it's positive. So you're going to have that. Then you find the result and 7.35. 7.35. Okay, are we all getting that? Nangu kutari fetshadire, guys. Alright, so now we just have to resolve our force into Cartesian form. And that is going to be our force in Cartesian form, which is force what? force B, force BC is going to be equal to the magnitude of our force over our the magnitude of our times what? Times so it's going to be this, right? Yeah. So what we do is we replace. Our force was what's the force? So 600 over 7.5 times what this? Okay, it's going to be that. Guys, twaluva papeni. What are you getting? Guys, and then me, I told you to round off Kumalas. You're rounding off, don't avoid rounding off sana before tawulafika kunani gani. Tawulafika ku final answer, but I round off the final answer. So you get what? You get 258.69. 0.78. Okay, and then go from there and the 0.78 plus what? Plus 489.8. Okay, is it minus? Minus what? 231. Point what? Could it be? Mm. Eh? Okay, guys. Okay, guys. Answer from either way. Okay, you get that. So now let's find the moment. Okay, so our moment is going to be equal to I minus J. There is another way of finding this without writing this the determinant number nindaba. So guys mnejobba sana. Okay, so fine, you tell me the answer. Yes. Yes, isn't that our R? This one. Oh no, this yeah. Guys. What was our R? 2.83. Then we had 0 here. Negative 1.17. Does this, right? No, it's not. I wasn't the one rounding off. Hey, it's a book.
Negative. Isn't it negative? I want to positive. Like the I. It's so positive. These are negative, are positive. But
What are the answers, guys?
we have found negative 573 I.
-5.
Yes.
How? Supposed to be positive. Supposed to be positive because this one times this one, it's positive.
There's a negative. Okay. There's a negative. Here, there's a negative. When you do this one like this, then it's very initially there's a negative. Yes. Yes. The negative. It's positive.
Okay, we found. Guys, tamnasanga. Winda. Wasanga. Not it. Okay, you found. Alright, so maybe it can be off by a number, some points. It's still correct, just depends on how you are doing what. You're rounding off, okay? Not by 2 points, no, that's a lot. Yeah, that's a lot.
This one.
Hmm?
Plus.
Those questions are easy. Okay, so we have found. If you want, you would have used your arrow would have been from. It would have been like this. You would have moved from here to here. Okay. Yeah, you'd have. This would have been your R if you wanted. Okay. Yeah, it still give you the same answer. So that one would have been, you would have had what? 6 here, and -4 here. This one would have been easy. No, you still have to resolve here for for, for the force, but still. So you need to see. Right, what's the time? 17:30. I give you another question about an axis, about a specific axis. Which question was about a specific axis? Question 7. Question 7. Okay, question 7. Right.